This is the Earth Science Classroom. Welcome back to the channel. This video is on the Atmospheric Science Unit and the lesson planner. So I like to go through these planning sessions with everyone because in my classroom I have a set way of doing things, but I like to get things organized, and I definitely backwards plan in regards to any units or large amount of lessons that I'm going to do on a certain topic. So this case, it'll be the Atmospheric Science Unit. And I always start with thinking to myself, how can I build the students' knowledge? How can I build it in a step-by-step logical sequence going from the basics and hopefully a good starting point for their level, and then build on that piece by piece until we get to a more cumulative and overall appreciation for the topic at the right level. Now again, this is high school level, so students age 14 to 18, and trying to bridge that gap between middle school science and earth science, which is kind of introductory, to the college level, which can be perhaps a little bit too advanced sometimes, or bring in too much math and physics, especially in the Atmospheric Science Unit. So I always start with the why we're doing this and the importance of understanding or learning about the atmosphere. So the atmosphere is a very complex layer of gases that act as a fluid, but also you can bring in a lot of atmospheric chemistry, a lot of atmospheric physics with thermodynamics, and looking at how heat is transferred throughout this medium around the world. You can also look at the environmental science aspect, which is looking at climate and biomes and the interaction of humans with our atmosphere and the knock-on effect or cause and effect or feedback loops that occur between the oceans, the terrestrial land surface, the human element, and also the atmosphere. So I do a poster. I do an atmospheric poster which looks at the temperature and pressure profiles, the four layers, the troposphere, stratosphere, mesosphere, and thermosphere, and looks at kind of detailing those layers as an introductory assignment. Then we go into the basics of the Sun-Earth energy budget. So what the sun is giving us in terms of radiation, the EM spectrum, the amount of energy, and what the Earth does with it in terms of the amount of reflected energy and albedo to the amount of energy that's absorbed, both with clouds, the atmosphere, the oceans, and inland, and also looking at basic greenhouse effect greenhouse gases. Then looking at the tilt of the Earth, the inclination, and how this creates basic seasons, and also how this creates a uneven heating and distribution of heat along or around the Earth's surface. So the equator and the equatorial regions get more concentration of sunlight compared to the North and South Pole and the polar regions. So look at that in terms of how there's a difference between the hot equator and the colder poles, and why that is in terms of concentration. Then we look at how this uneven amount of energy is distributed as best as possible by the atmosphere. Now it also happens with the oceans, but in this case we're looking at the atmosphere in particular, and how this creates rising air and sinking air. So when the air is heated, it's going to rise. When the air is cooled higher up in the atmosphere towards the tropopause, that would cause the air to descend and sink, thus creating difference in pressures. Low pressure where the air is rising, high pressure where the air is sinking. And we get these large convective atmospheric cells, the Hadley cell, the Ferrel cell, and the polar cell, being created around the Earth, north and south of the equator, as a symmetrical system, and how this distributes heat from the equator to the poles, and the cold air comes back from the poles down back towards the equator. So this creates both trade winds, westerlies, easterlies, and also creates belts of pressure, high pressure and low pressure. And we can discuss that system off from an anticyclone to a cyclone system. Then we can look at the jet streams, look at Rossby waves. We can look at the air masses that are created from the movement of heat and air moving. So looking at the trade winds and air masses in particular for the mid-latitude cyclones, which is a low pressure system dictated and controlled by the jet streams. So this all comes into one understanding, one big system. Then we can look at frontal systems and how the cold air and the cold air mass, where it's come from, whether it's dry or wet, versus the warm air, again, dry or warm. Comes over land, it's dry. Comes over the water, it's going to be wet. and how these frontal systems work. Now, we can also look at how to get into how the air lifts and what happens when that air is lifted. So is that going to be dry air lifting up, or is it going to be wet or saturated or damp air lifting up? Now, when you lift up air in the troposphere, you get a decrease in temperature. So the higher you go, the colder it gets. And it'll get to a point where the water vapor in the atmosphere, as it's lifting or being forced to lift in different types, will eventually condense and release that latent heat and create clouds and cloud formation process, like the Bergeron process. And we can get into the dew point, the LCL, the adiabatic lapse rate, both dry and saturated, and look at how this affects the type of clouds that are formed and the altitude, and look at the kinds of precip that would follow. We can look into thunderstorm development as well, with that latent heat being released and allowing for air to continue to rise up, creating vertical cloud formations. We can also look at the very end, is looking at weather stations, how to collect, measure, and record data of atmospheric conditions in a certain location. So wind speed, dew point, humidity, and look at how to forecast and predict weather based on a synoptic chart, and where the fronts are, where the pressure is, where the high pressure is versus low pressure, and you can figure out wind direction and the air masses and the potential for various conditions to create or be created based on the available data and the weather station models that we're looking at, so students can have a chance to actually forecast weather in the area. So we're based in New Jersey. They would look at forecasting for New Jersey in a current 1 hour prediction, 1 day or further afield, 2, 3, 4 day prediction based on the charts given to them. So the plan is to build a sequence of information on the atmosphere, so at the end of the day they'll understand not only just cloud formation and systems of weather and climate, they can also look at individual locations and look at the current conditions and have the background knowledge of the sun's energy and GCMs and jet streams and how heat is transferred to understand how the weather is forecasted by meteorologists, and also look into building our knowledge towards extreme weather. Things like thunderstorms and lightning and typhoons and cyclones, hurricanes, and all the different natural phenomena that comes with those extreme weather events. This is the Earth Science Classroom. Thank you for watching. I hope you enjoyed the content. Check out more videos on our channel, and don't forget to subscribe. Thank you again.